All right, you guys, so this lesson on special products is actually just a continuation of multiplying polynomials. Really, as if you know FOIL and if you know how to multiply binomials, then you automatically know this stuff. The only time I actually use these rules is when I'm doing the fill in the blank questions that you see on that page. So when you're squaring binomials, it means you have two binomials that are exactly the same. For example, if I gave you something like 2 or x plus 3 times x plus 3, you have a binomial times a binomial, and it's exactly the same. You could go through the motion of FOIL. However, if you know these rules, it kind of makes the question a little bit easier. So when you're squaring binomials, what you can do is you can take the first term and you can square it to get a squared. You can take the last term and square it to get b squared. And to get this middle term, you basically multiply a times b times 2, and you can get the middle term. So instead of doing first, outer, inner, last, it's just another method to multiply two binomials. And you can only use this method when the binomials are exactly the same. So let's go ahead and try practicing this rule. Does this look familiar to you? Yes, but you may not remember it all the way. Okay, so just make sure that you memorize these rules. You take the first one, first term, square it, second one, square it. The middle term is just a times b times 2. And then whatever the sign is inside the bracket in the question, it remains the same for the middle term. Okay, so I have 3x plus 1 squared. What I'm going to do is I'll actually use the little trick that we just learned, and then we can confirm our answer by actually foiling it and see if we get the exact same thing. So according to my rule, what I'm going to do is I'm going to take the first term and I'm going to square that. So 3x squared is basically 3x times 3x, which is going to give me 9x squared. Then I'm going to take the last term and I'm going to square that. 1 times 1 is a 1, so I'm going to put the 1 somewhere over here. It's my last term, which means it's going to be the last term in the answer as well. To get the middle term, what you're going to think of is you're going to take 3x times 1 times 2. So you're basically multiplying the first term here, the second term here, all by the number 2. So 3x times 1 is just 3x. 3x times 2 is 6x. That means our middle term has to be 6x. And the sign is going to be, if it's a plus, then it's going to be a plus and a plus everywhere. So it's going to be plus and then plus. I kind of wrote this super messy, so I will just write it out again. My pen stopped working. Yeah, it did. Am I even signed into the Zoom right now? Okay, so let's go back here and okay, so hopefully that explanation made sense. I'm going to rewrite this so it actually looks a lot neater, and it's going to be my still, yes, I am. So it's going to be 9x squared plus 6x plus 1, and that's our final answer. To confirm this, let's just go ahead and use our foiling method and see if we actually get the exact same answer. Obviously, we should, but I'm just trying to prove to you that it doesn't matter which technique you use. You can either use the little trick or you can use FOIL. You will still get what you're supposed to get. Okay, so on this side, now I'm going to go ahead and just use the orange, and it's going to be, this is basically like saying 3x plus 1 times 3x plus 1. 3x times 3x is 9x squared. 3x times positive 1 is 3x. 1 times positive 3x is 3x. And 1 times 1 is 1. And then you clean it up and you get 9x squared plus 6x plus 1, which is exactly what we got before. Does this little rule make sense? Yeah? Okay, let's try the next one. It is 3x minus y, all of it squared. So we're going to take the first term and we're going to square that. So 3x times 3x again is 9x squared. To get the middle term, you're going to take the first term, which is 3x. You're going to take the second term, which is y, and you're going to multiply the whole thing by 2. 3x times y times 2 is going to give me It's going to give me 6xy. And because there's a minus sign in the original question, that means my second term will also have a minus sign. And then the last term is going to be y times y, which is y squared. I'm not going to do it, but if you really wanted to prove this to yourself, you could go ahead and FOIL this and you will notice you're going to get the same answer. Now, when is this important? It's really important for these fill in the blank questions. So I'm going to give you, actually, we'll do maybe one or two of them together, and then the rest of it will be for homework. So let's go ahead and do you guys have a preference, or should we just randomly pick some? I don't want to, oh, you know what? We don't have to do the decimal one. You can cross out question H, but we can do the ones with the fractions. Those are fine. Let's try question D. Question D is a good one. Actually, they're all good, but let's try question D. So we basically have a number minus another number, all of it squared, and it's equal to 16w squared minus some number plus 49. We're going to work backwards. If I know this right here is 16w squared, what two numbers must you have multiplied to get you 16w squared, Rahiman? Really close. 8 times 8 would give you 64. What other two numbers? You want to try again, Rahiman? You want to do it again? No? Okay. Rubaru? This is going to be 4w. Good. And then what two numbers must you have multiplied to give you 49? Tanita? 7. And then how do you get the middle number? Well, you're just going to do 4w times 7, which is 28, times 2, which is going to give me 56w. Bea? It's actually just part of the, yeah, it's part of the rule. So see in the middle term right here, you take A times B times 2 to get the middle term. So we're just following kind of a formula. It's going to be 56w, exactly, because you're multiplying 4w times 7 times 2. 56w, yeah. Okay, let's try maybe one more. Shall we try one with a fraction? Okay, let's do question I. So here we have a number plus s, all of it squared is equal to 1 over 9 plus something plus something. So I'm going to go ahead and start with this one over here. I know when I have an s, and I'm going to try to get this last term, I'm just going to square this. So what's s times s? Good. So this is going to give me s squared. If I have 1 over 9 over here, what two fractions must have multiplied to give us 1 over 9? Janisa? It's going to be 1 over 3. Now to get the middle term, you're going to go 1 over 3 times s times 2. I know you can't see that, so I'm just going to move it over. There we go. 1 over 3 times, that's not a 5, it's supposed to be an s times 2, and that gives me 2 over 3s. Okay, do you guys kind of get what you're going to do for this this part of the homework? Yeah, all the answers are at the bottom. I hope there are no mistakes, but you guys can try those. Yeah. Sure. Okay, so whenever you have a binomial, like any sort of binomial squared, to get the middle term, what you do is you take the first term. So see how the first term in that example is a 3x. Then you take the last term, and the last term is y, and you multiply all of that by the number 2. So it's 3x times y times 2, which is 6xy. In this example, we're going to take 4w times 7 times 2. So 4 times 7 times 2 is 56, and then there's still a w there. And then over here, we did 1 over 3 times s times 2, so it'll be 2 over 3s. Does that make sense? Okay. Any other questions? You guys are good? All right, last but not least, let's go on to multiplying conjugates. I'll just do the 2 examples here. So what are conjugates? Let me actually write down 3 examples and see if you can see the pattern. So an example for conjugate would be, go over here, 2x plus 3 times 2x minus 3. Or a minus 5 and a plus 5. Or x minus y and x plus y. What do you guys, what pattern can you tell me is true for conjugates? Sarah? Exactly. So the binomials are exactly the same terms. The only thing that differs is one has a plus and one has a minus. Whenever you have two conjugates that you're multiplying, again, you could use FOIL, you could do it the old-fashioned way, but the short form is you just take the first two terms and multiply them, you take the last two terms and multiply them, and you put a negative in between. So let's try this with the first one. We have 2x plus 5 and 2x minus 5. We're going to use our shortcut. So I'm going to multiply the first two terms, which are 2x times 2x, and that is 4x squared. I'm going to multiply the last two terms. 5 times 5 is 25. And then the sign in between them is just going to be a negative. This is a shortcut. If you did not want to do this, you could have just gone ahead and FOILed it. And it's not like I would ever ask you to use, like I would never say you have to solve this question using the rule. It's just sometimes if you, especially if you can get really good at it, it saves you a lot of time to use the pattern. Okay, so just on the other side, I'm going to go ahead and do the old-fashioned way. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Positive 5 times 2x is positive 10x. And positive 5 times negative 5 is negative 25. And you're left with exactly the same thing, which is what we got in that first example. Oh, now this is actually really bothering me. Oh no, now I erased too much. Okay, there we go. Okay, let's do the question, Bea. Because what is b? B is 5 and 5. So 5 squared would be 25. Does that make sense? Yep. Okay. All right, last one. Let's go ahead and solve this using our pattern to save some time. I see I have a random 2 in the front. I'm just going to deal with that random 2 later on. I'm going to first multiply the binomials. So I'm going to use a shortcut. I notice they're conjugates. I'm going to multiply 4x times 4x to give me 16x squared. I'm going to multiply 3y times 3y to give me 9y squared. And the sign in between is going to be just a negative. Then I'm going to distribute the 2, and I'm going to get 32x squared minus 18y squared. That is the final answer. Hopefully you guys can see the value in doing this and how quick it is and efficient. And honestly, the more patterns you learn in math, I just feel like it makes you so much faster at it. Okay, your homework for this part is going to be these questions here. Questions 3, 4, 5, and all of those, the solutions for those are posted as well, are at the bottom as well. I'm going to stop the